In this video, we'll be learning how to multiply complex numbers. So in order to understand how to multiply with complex numbers, we need to understand how the powers of I actually work. So there's some really cool properties we're going to walk through pretty quickly that we're going to then use to our advantage. So I, we know, is equivalent to the square root of -1, and I we're always going to represent in math as just a regular I. However, all of the rest of these exponents can actually be simplified down to just something that contains a number or an I. So we're going to look at each one and simplify it down. Remember that I squared, if we take I, which is -1, and we square it, that would undo the square root here. So I squared, every time we see an I squared, we can actually rewrite it as a -1. And so those are actually equivalent. I squared, because of the definition of I being the square root of -1, can just be rewritten as -1. Now, I cubed might look like something that can't be simplified down to just I, but it can. Because of our exponent properties, I cubed can be simplified down to I squared and I to the first, because 2 plus 1 is 3. And we just learned that I squared is a -1. So I cubed is really equivalent to -1 times just I, or you can write it as a -I, whichever one you prefer. But again, I cubed is a number that can be simplified down to just a -I. And then finally, I to the fourth, this is another one where we can rewrite it as I squared times I squared, which is -1 times -1, which is equivalent to 1. So you can see how those first four simplify down to either I, -1, -I, or 1. So now if we take a look at these larger ones, what you're going to see is there's actually a pattern that results. So I to the fifth, again, if I use my exponent properties, I can do I to the fourth and I to the first. Well, I just learned that I to the fourth is 1. So this is equivalent to 1 times I, or just I. And notice we're back up here. Then I to the sixth. We can split this up into I to the fourth times I squared, because 4 plus 2 is 6, which I to the fourth we learned is a +1. I to the second we've learned is a -1. And as a result, this is -1. So notice how we're coming back through with this same pattern. Then I to the seventh we can split into 4 and 3, because 3 plus 4 is 7. I to the fourth we know is equivalent to 1. I to the third we know is equivalent to a -1I or -I. So I to the seventh is equivalent to -1I or a -I, however you want to write it. And again, we're coming back down with this pattern. It's kind of repeating through. And finally, I to the eighth can be written as I to the fourth and I to the fourth. Well, I to the fourth is always equal to 1, so this is really 1 times 1, which is 1. So what happens here is this pattern repeats through. We have I, -1, -I, 1. I, -1, -I, 1. And we can use that to help us simplify down anything with an I that has an exponent. So let's take a look at some new examples with some higher exponents. So the key here to remember is that I to the fourth is equal to 1. So if we can break these up into groups of I to the fourths, we can then simplify it down to something with a much smaller exponent. So if we start off looking at 17, I'm going to break this up into I to the fourth times I to the fourth. That's going to give me 8 of those 17, times I to the fourth, there's 12, times I to the fourth, there's 16, times I to the first. So I've broken this up so we have 4 plus 4 plus 4 plus 4 plus 1. Now we know that all of our I to the fourths are equivalent to 1. And then we're just left with I to the first at the very, very end. So I to the 17th, because of the way that that pattern with I results, we have, 4 of those I's are 1, 4 of those I's are 1, 4 of those I's are 1, 4 of those I's are 1. So we're really just left with I to the 17th is equivalent to just plain old I. Now if we look over at I to the 40th, the shortcut here that we can kind of think through is we can look at this number, and if this number is divisible by 4, we know that it's going to have a bunch of I to the fourths that are equivalent to that number. So because we have I to the 40th, and 40 divided by 4 is a nice equivalent 10. What that's telling us is we're going to have I to the 4th times I to the 4th, and it's going to be multiplied by I to the 4th a total of 10 times. And because there's a nice solid number of I to the 4ths and there's no i's left over, we know that this is going to be a bunch of 1 times, all the way through. And as a result, I to the 40th is equal to 1. So now if I look down here at number 3, what I'm going to try to do with this 34 instead is break it up into something that is divisible by 4. Because I know that if something is divisible by 4, like 40, that exponent with I is going to result in just a 1. So when I look at 34, I know that 34 isn't divisible by 4. But I know that I can break this up into 32, which is divisible by 4, and 2. And so because this 32 is divisible by 4, that repeating pattern that we see, where anything that's divisible by I to the 4th is equal to 1, we know that this I to the power of 32, because 32 is nicely divisible by 4, we know this is equal to 1. And then we have I squared, which we know is equal to a negative 1. And so now here as a result, we have 5 times 1 times negative 1, which is negative 5. And then finally here with this last one, we're again going to break up 23 into whatever number that is just below it that is divisible by 4. So I'm going to start here. I'm going to leave the 7 alone, but I know that 20 is divisible by 4. So I'm going to break the 23 up into I to the 20th and I to the 3rd. We know that because 20 is nicely divisible by 4, that I to the power of 20 is just 1. And then we know from the previous slide that I to the power of 3 is just a negative 1 times I. So here we have 7 times 1 times negative I, which is a negative 7I. So now let's practice multiplying, and we're going to use these powers of I to help us out. So we know that when we multiply things in parentheses, we take everything in the first parenthesis and we multiply it by everything in the second. So we're going to take 6 and we're going to multiply it by 5 minus 3i. And then we're going to take 4i and multiply it by 5 minus 3i. So I like to write it out this way so I can see I don't miss a distribution. But 6 times 5 is 30. 6 times negative 3i is negative 18i. 4i times 5 is 20i. And then 4i times a negative 3i is a negative 12i squared. So now we can combine together our like terms. But before we do that, I want to keep in mind that we have a new property we can use that allows us to simplify this piece right here. So we have this 12, so it's really negative 12, and then we have I squared. We know from a previous slide that the I squared is a negative 1. So we're going to rewrite that there. So really we have 30 minus 18i plus 20i, and then we have this negative 12 times negative 1, so that is a positive 12. And now from here we can combine like terms. 30 plus 12, that's going to be 42. And then we have negative 18 plus 20i, which is a positive 2i. And so now at this point we've distributed and we've added together all our like terms. And two final examples here. So in this first one, we're just going to have a single distribution. Negative 5i times negative 7 is a positive 35i. Negative 5i times 9i is a negative 45i squared. Again, anything with an I, we're looking to make more simple. And so here we can see this term has an I squared. So we have negative 5, and we know I squared is equal to negative 1. So we really have 35i plus 45. And our final example here, we're just going to practice squaring. So remember, squaring, you take whatever is in the parentheses and you multiply it times itself. And the easiest way to avoid an error is to write it out twice. And then we take everything in the first parentheses, so we take negative 4, and we multiply it by negative 4 minus 11i in the second parenthesis. And then we take our negative 11i, and we multiply it by negative 4 minus 11i in the second parenthesis. And then finally, we just distribute. So here we're going to take negative 4 and distribute it out. So we have negative 4 times negative 4 is 16. Negative 4 times a negative 11i is a positive 44i. Negative 11i times negative 4 is another positive 44i. And negative 11 times negative 11 is a positive 121. And then the I times I gives us I squared. Now remember, anything with a power on I we can simplify down. And so here, this is really 121 times negative 1, which is the equivalent to I squared. And so here we have 16 plus 44i plus 44i plus a negative 121. And then we just combine together like terms. I see that the 44i's combine together to be 88i. And then I see that I have 16 and negative 121, which combine together to be a negative 105.